Welcome to the Introduction to Economics from Park Bench Tutors. This brief presentation is brought to you by David Hopcroft. In this podcast, we are going to take another look at production. The production of goods can be expressed in terms of functional notation. It may look a little complex, but all that this means is that we can express the output of X as a function of the input of capital, the input of labor, and the input of land or resources. When we use the term a function of, we are saying that it depends upon. We have not indicated a precise relationship, we have just indicated the variables here. For the purpose of this podcast, we are making one assumption, that the technology is not changing during the time periods being considered, and that the methods of production are technologically efficient. We need some simple measurements to start with. How much will each worker produce? In other words, what is the output per worker? To obtain an average value, we need to divide the total units produced by the number of workers employed. If AP is the average product, TP the total product, and L is the number of workers, then AP equals TP divided by L. Now we need to define the marginal product. Marginal product refers to change. If we add another worker, then how much does the output change? Each time we add another worker, there will be a marginal change. In mathematical symbols, we use the delta symbol to represent a change. So if MP represents the marginal product, then MP equals delta TP divided by delta L. Economists have found that when additional workers are added, the total product will start to increase, but only to a certain point. At some point, the continued addition of workers will actually have reduced effects, with the average product and the marginal product both starting to fall. This is referred to as the law of diminishing returns. Here is the law illustrated by means of a chart. Note that at first both average product and marginal product are increasing, but then both marginal product and average product start to decline. The production of goods over a short run has been considered. One variable can be altered whilst others remain fixed. In simple terms, this means that if we have two variables that are fixed, then increasing the third variable will increase output to a certain point. Thereafter, the output will fall. Let's just look at the law once more. We are considering the output per worker for the production of X where other factors remain fixed or constant. Initially, as additional workers are added, the output increases. As we continue to add workers, the effect upon output is reduced. Eventually, we reach a point where adding additional workers will reduce average and marginal outputs. The introduction of labor in small quantities, for example introducing extra labor into a factory that employs 300 or more workers, would show smaller changes, and plotting these effects would give us smoother curves for average product and marginal product. The point A represents the point of diminishing marginal returns. Adding additional workers after this point will reduce marginal product. The point B represents the point of diminishing average returns. Note that the curve for marginal products cuts the average product curve at its maximum point B. Remember that average product, AP, is equal to total product, TP, divided by the number of units of variable factor. In the previous example, we chose labor. So average product is the slope of the ray from the origin to the point on the curve for the total product. Consider the point where L1 units of the variable are used. The average product will be the slope of the ray OA. This slope can be calculated by dividing AL1 by OL1. I will just repeat that for you. Consider the point where L1 units of the variable are used. The average product will be the slope of the ray OA. This slope can be calculated by dividing AL1 by OL1. The average product will be at a maximum where the ray from the origin is at a tangent to the curve for the total product. This occurs at point C on the diagram, where the slope is given by CL2 divided by OL2. Up until the point of OL2, then increasing units of the variable will increase average returns to the variable factor. The weakness of the model is that it assumes the technology remains constant, whereas in practice there are usually continual changes in technology. Over a long run, all the factors in production are variable. A firm should aim to minimize the production costs, so the firm should attempt to employ a combination of capital, labor, and land which achieves this objective. Cost minimization can be shown graphically by the use of Isoquant and Isocost lines. Remember, iso means same, so Isoquant, same quantity, Isocost, same cost. The diagram here assumes only two factors are employed, those of labor and capital. It also assumes it is possible to substitute between labor and capital continuously. Point A on the isoquant Q1 represents one possible combination. There are OK1 units of capital and OL1 units of labor. An output of Q2 units can be achieved using any point on the Q2 curve. Similarly, an output of Q3 units can be produced using any point along the Q3 curve. The definition of an isoquant curve is a contour joining points where different combinations of two factors of production will produce the same quantity of goods. Right, isoquant, same quantity. There are three important properties of isoquants. Isoquants cannot intersect. The diagram shows a point H which suggests that combinations of labor and capital can produce different outputs, but this cannot happen. Both capital and labor have positive marginal products. That is, the employment of extra units will increase output. To maintain a given level of output, it follows that if we increase one factor, then the other factor will be reduced. Isoquants are convex to the origin. In very simple terms, all that this means is that if we continually substitute capital for labor to produce the same level of output, then it becomes less and less capable of substituting for labor. The slope of an isoquant represents the rate at which capital can substitute for labor. The slope is called the marginal rate of substitution of capital for labor. Suppose that we have a fixed amount of money. What are the combinations of capital and labor that can be employed? The results of the combinations show isocost lines. In this example, we are assuming that we have $20 and that labor costs $2 a unit and capital is at $1 per unit. Understanding the table is fairly simple. When there are 4 units of labor at $2 per unit, then $8 is used for labor and the remaining $12 used as capital. The isocost line AB shows the results of the combinations using $20 as an outlay. The slope of OA divided by OB, which is 2, represents the relative factor-price ratio, or that each labor unit is twice the capital unit. The isocost line A-B- shows the result for an outlay of $40. A-B- is the line for an outlay of $10. If there is a change in the relative factor-price ratio, then the slope will change. The desire of any firm should be to produce the good at a minimum cost. This point is the point where the isoquant is just touching its isocost line, or where the isocost line is the tangent to the isoquant. For isoquant Q1, the point is at C. C is the point of cost minimization. Joining these points for different isoquants produces the expansion path. Economists make the assumption that if they employ more labour and more capital, then the output will increase proportionately. This idea is referred to as constant returns to scale. If you double the quantity of labour and double the capital, then the output will double. If this does not happen and the output more than doubles, then we say there are increasing returns to scale. If the output fell, then we would say there are decreasing returns to scale. Now, if my diagram were drawn perfectly, this would be represented by the fact that OL1, L1L2, and L2L3 would be equal in length. This ends our short broadcast on isoquants and isocost lines, brought to you by David Hopcroft of Park Bench Tutors. Thank you for watching and for listening. We wish you every success in your studies.